Today is the 10th of July 2023, and we want to have a look at the topic probability. We've been looking at percentages, decimals, fractions. We've done mathematical symbols. We've done a lot of things. Okay, so we've done enough to help us understand the topic probability. Okay, now this is a very interesting topic if you understand the basis. So if you understand the basis, you should be able to solve or maneuver any question thrown at you. Okay, let's look at this. The probability is always from 0, impossible, to 1, certain. Okay, so 0 is an event that cannot happen. Okay, to 1, an event that is certain. Okay, so maybe it is certain that it may rain, okay, today, or it is 75% likely that it will rain, or in winter it is impossible to have the sun, very, very hot. Okay, so, or in a summer it's impossible to have snow. Okay, so these are the things that probability throws at us, and it's between 0 to 1. So if you look at the scale here, I've drawn a scale for you. Probability is 0, okay, impossible. So in winter, you can't expect the sun to all of a sudden maybe go to 35 degrees. Okay, it might go a little bit higher after snow, but you not expect a hot day in winter. Either will you expect a very, very cold, freezing night in summer. I hope I'm clear. So the halfway is the 0.5, so it's the even chance. So it may or may not happen. And then here it is certain. Okay, you have day and night, so that is a certain event. You will always have day and night in every 24 hours. Now between 0.5 up to 1 are the likely events. Okay, and between 0 and 0.5 these events are unlikely. It might happen, but there is a slim chance. Okay, now probability is never less than 0, so you can't have probability in negative numbers. Is either 0, okay, or is between 0 and 1. So you can't have probability like minus 0.1. We never have that. And probability is never greater than 1. So you can't have a probability answer of 1.5. Okay, so anytime you have an answer in probability which is in negative or greater than 1, then that should also give you a clue that maybe you've done something wrong. That is why you are getting that answer. But immediately it comes to probability, you should be thinking about answers between 0 and 1. Okay, I hope I'm clear on that. Okay, so you can either put probability in decimals. We've looked at decimal. So 0.3, 0.31, 0.7, or in a fraction form, 1/4, 3/8, 2/7, okay, or in percentage form, like 45%, 20%, 81%, or sometimes in 1 in 3. So maybe 1 red and 1 red in 2 yellow dice will give you 1 in 3, okay, or 2 in 3, or 1 in 4. Okay, this might be the language they will use to frame questions for you, if it's not like solve or this. So if you are reading the question, you should be looking out for some of these figures in this form, because in a question they can decide to mix 2 or even 3, and then so that they will see how your thinking pattern is on the topic. Okay, so you might have to read carefully and see what the question is asking you. Okay, so an example of an impossible event is like you have a 2 months old. That 2 months old is not going to turn 50 in 24 hours. It is something that can never happen on this planet. Whatever you do, a 2 months old in 24 hours cannot even turn 18. They have to go through the process of growth. And then a certain event, okay, today is the 10th of the 7th of 23. You can't go back and say to somebody, oh, today looks like the 10th of the 7th of 1980. It's not going to happen. We are moving forward. We are not going backwards. So today's date is officially this. Okay. So you can come back and say that, oh, so that is also a certain event. Okay. All right then. Let's move on. So in probability, today I'm going to discuss 2 basic event types with you. Okay, so now that you know that a probability can be an impossible or a possible event, okay, and I've shown you the scale, okay, you can have a dependent event or you can have an independent event. Okay, so let me tell you what I mean by that. So a dependent event can affect the other event. So this event is one event that can affect the other. So a previous event can affect a present event. Okay, what I mean by that is, assuming you went to school today, okay, it can affect how much homework you are given. Okay, now let's look at an example of a dependent event. So for instance, you have 7 pegs in the bag. 3 is yellow and 4 is white. Okay, so together you have 7 pegs. Okay, the probability of picking a yellow peg is 3 out of 7. that is your first event. But when you picked the yellow peg, okay, 3 out of 7 because you have 3 yellow pegs, okay. Now, when you pick the yellow peg the first time, you did not put it back in the bag. So now, because you've picked the first peg yellow, okay, now you have 6 pegs, and you have 2 yellow and 4 whites. I hope I'm making sense. So because you didn't replace that yellow peg, okay, your first probability of picking the first one is 3 out of 7. So now, depending on the second event, okay, the second event will depend on your event 1. So if the first time you pick the yellow, now you have 2 yellow pegs and 4 white pegs. So now the probability of picking another yellow will be 2 out of 6. If you reduce it to the simplest form, it's 1 over 3. But it's a peg. The peg is now 6, 2 yellow and 4 whites. Okay, so assuming you didn't get a yellow this time and you pick a white, okay, the probability of picking, if you pick the white, then the probability of picking another yellow peg will be 3, okay, because assuming you pick a white in the first event, then you have 3 now, okay, and then you have 6 6 pegs, so it will be 3 out of 6, okay. So sorry, so let's quickly go over what I just said. So assuming you have 3 yellow and 4 whites, the total is 7. Assuming you dip your hand in the bag, okay, and you pick a yellow peg, your probability will be 3 over 7, okay. If you pick the white, it will be 4 out of 7, but you want a probability to get a yellow peg, so it will be 3 yellow out of the total of 7. That will be the first event. So if you pick the yellow peg, you have your event 1 probability is 3 out of 7 in fraction form, okay. Now you want to pick another peg. You don't know what you are going to pick, but now you have a total of 6 pegs, okay. Of the 6 pegs, 2 is yellow and 4 is white, because now we are certain that you picked a yellow peg. So if you are going to pick another yellow, then your new probability now will be 2 over 6. If you reduce it to the lowest form, it's 1/3. But assuming you went in this bag of 6 pegs and 4 whites, okay, and you picked a yellow, okay, a white first, then you still have 3 yellow pegs, okay, and then it's 3 out of 6, which is half. I hope I'm clear. So this is called a dependent event. Your probability depends on what happened in the previous event. Now, the independent event, okay, is straightforward. Independent means it doesn't depend on anything. So for instance, if you have a dice and you throw it, Okay, the probability of getting a 1, a 2, a 3, 4, 5, 6 is 1 over 6. Okay, so your first row will be 1 out of 6. If you throw it again and you get a 2, your probability of getting a 2 is still 1 out of 6, because you have only that 1, 2, and 6 outcome. Do you get what I mean? So the probability of getting a 1, 2, 3, 4, 5, and 6 will always be 1/6, whether you throw it 100 times or not. I hope I've made some sense here. So this is an independent event. Okay, so let's put this on the side and let's quickly look at another example. Another independent event is the tossing of a coin. We know that a coin has two sides, okay, the head and the tail. So when you toss a coin, you either get a head or a tail. Okay, so if you got a head the first time, the probability will be half. That is not dependent on the fact that, oh, because you got a head, the second time you get a tail. You can throw it 10 times and you can get 10 heads. And you can throw it 10 times and you can get 10 tails. Okay, so because here we don't have to be throwing it and not replacing, each time you throw that coin, you are going to get half. So if you get a head, your probability will be half, or 50%, or 0.5. And if you throw it again and you get a tail, your probability will be still half. Okay, so today we've looked at probability. We said it's an impossible event. The scale starts from 0 to 1. Probability will never be less than 0. It will never be a negative number, and it will also not be greater than 1. So you not have a probability greater than 1. Okay, and we gave some examples, and then we have looked at dependent events, okay, and how a previous event can affect the present event. And we've also looked at independent events, like throwing a dice or throwing a coin. Okay, so this is what I have for you today. All right, so tomorrow we'll have a look at some questions to answer on probability. If you understand this basic principle in probability, you should be able to think through any probability question and get some marks. Okay, so thank you for watching, and I'll see you in the next lesson.